The trucking industry is the lifeblood of America's economic infrastructure. It moves approximately 72% of all freight in the United States and generates over $940 billion in revenue annually. Yet beneath this economic powerhouse lies a significant environmental challenge: diesel emissions. Heavy duty trucks, which represent just 5% of the vehicles on the road, account for nearly 25% of total transportation related greenhouse gas emissions. We stand at a pivotal moment in transportation history. The traditional diesel powered trucking model is facing unprecedented transformation. The heavy duty zero emission vehicle market is rapidly evolving, driven by aggressive state and federal regulations, technological advancements, and increased economic incentives. California's advanced clean truck regulations and the federal government's clean truck plan are pushing the industry towards a dramatic shift, with mandates requiring manufacturers to progressively increase zero-emission truck sales. The heavy-duty vehicle inventory and planning program represents a crucial bridge between policy ambition and practical implementation. By providing substantial financial incentives for fleet operators to transition to zero-emission vehicles, HVIP is not just subsidizing a technology shift, it's fundamentally redesigning the economic calculus of commercial transportation. With incentives ranging from $150,000 to $385,000 per zero-emission truck, the program is making what was once considered an aspirational goal into a tangible, financial, viable reality for trucking companies across the nation. I'm Brian Loomis, and I work at Nikola Motor. For the last 15 years, I've focused on software development and consulting in the clean energy ecosystem. That experience has covered developing data transmission protocols and monitoring and alerting systems in the locomotive freight industry using diesel-electric technology, and it includes energy calculation and recommendations for commercial buildings and energy conservation measures for smart cities. For the last 2.5 years, I've worked with Nikola Motor to lead the data engineering and data science efforts in the cloud. We are a customer of the conference sponsors Crunchy Data and use the analytics cluster and will soon use the data warehouse features. And while I've worked with databases for 25 years, PostGIS is very new. I was always aware of the community peripherally, and I'm only now just discovering the tools and techniques many of you have known for years. Briefly, what this talk will cover is what the California Air Resources Board is, ability to recognize the areas that are designated as priority populations, understanding what a priority population is, learning how to calculate when a vehicle is in an underserved area, and how to manage data at scale so the reporting is not overwhelming. Replacing the emissions of 23 conventional gasoline cars or a single diesel truck with a hybrid electric vehicle represents a significant environmental breakthrough in reducing carbon footprint and air pollution. A typical passenger vehicle emits approximately 4.6 metric tons of carbon dioxide annually, meaning the elimination of 23 car emissions translates to preventing roughly 105 metric tons of CO2 from entering the atmosphere every year. This reduction is equivalent to the carbon sequestration by nearly 175 acres of forests, or taking approximately 23 cars off the road. Diesel trucks, which are known for their substantially higher emissions, produce significantly more pollutants per vehicle compared to passenger cars. Beyond carbon dioxide, replacing these vehicles with HEV vehicles dramatically reduces other harmful emissions, including nitrogen oxides, particulate matter, and sulfur compounds. The environmental and health benefits extend beyond direct emissions reduction. Hybrid electric vehicles consume less fuel, generate lower noise pollution, and demonstrate improved energy efficiency compared to traditional combustion engine vehicles. The cumulative impact of replacing 23 cars or one diesel truck represents not just an individual transportation choice, but a meaningful contribution to mitigating climate change, reducing urban air pollution, and supporting broader ecological sustainability goals. Nikola provides two different vehicle types, a battery electric vehicle and a hydrogen fuel cell vehicle. Other manufacturers like Tesla, Volvo, and Daimler are developing long-haul electric trucks capable of ranges between 250 to 500 miles on a single charge. Current models target specific freight corridors and regional transportation networks. Hydrogen fuel semi-trucks present an alternative to zero emissions, particularly promising for long-haul and heavy-duty transportation segments. Manufacturers like Nikola, Toyota, and Hyundai are developing hydrogen-powered trucks with ranges exceeding 500 miles and refueling times comparable to traditional diesel trucks. These vehicles convert hydrogen into electricity through fuel cell technology, producing only water vapor as a byproduct, and offer potential advantages in weight efficiency and rapid refueling compared to the battery electric alternatives. The fleet incentive landscape for clean vehicles in the United States is a complex ecosystem of federal, state, and local programs designed to accelerate zero emissions vehicle adoption. At the federal level, the Inflation Reduction Act provides substantial tax credits for commercial clean vehicles. State-level incentives vary dramatically, with California leading the charge through the Comprehensive Vehicle Rebate Project and the Heavy-Duty Vehicle Inventory and Planning Program. These California initiatives offer substantial point-of-sale rebates. Other states like New York, Colorado, and Massachusetts have begun implementing similar programs. The exact voucher amount for these vehicles depends on the area. The Class 8 standard voucher range that we take advantage of provides an incentive between $120,000 to $150,000 per vehicle. Also, there are benefits available with the California Volkswagen Mitigation Trust, and that program offers statewide funding on a first-come, first-served basis to upgrade diesel-powered freight. Within California, disadvantaged communities and communities that are identified as having an economic impact from trucking and other means are the core of the requirements for whether vehicles are domiciled in disadvantaged communities. Disadvantaged communities face a disproportionate burden from the effects of climate change due to geographic and socioeconomic factors. DACs are those communities that are in the top 25% of the highest scoring census tracts using the California Communities Environmental Health Screening Tool. If we look closer at these communities, they stand at the front line of climate change. Climate change's most devastating impacts bear a disproportionate burden of environmental degradation and extreme weather events. Urban areas with high concentrations of low-income populations and communities of color are typically located in more vulnerable geographic zones, near industrial sites, in flood-prone regions, or areas with limited green infrastructure. These communities experience higher temperatures due to urban heat island effects, reduced access to cooling resources, and significantly fewer environmental mitigation mechanisms. The health consequences of climate change particularly devastate these vulnerable populations. Increased air pollution and rising respiratory disease rates directly correlate with socioeconomic status. creating a compounding cycle of environmental and health inequity. The California Climate Investments Priority Populations Database is a critical mapping tool designed to identify and support communities most vulnerable to environmental and economic challenges. Accessible through the California Environmental Protection Agency's screening methodology, the database utilizes the CalEnviroScreen 4.0 tool, which combines multiple environmental health and socioeconomic indicators to determine disadvantaged community status. Users can access the database through the Cal EPA website and use an interactive mapping solution to view areas or download the database for other projects. Navigating the database involves understanding its comprehensive scoring system, which evaluates census tracts across 21 individual indicators. These include pollution burden factors like particulate matter exposure, groundwater contamination, and traffic density, as well as population characteristics such as poverty rates, educational attainment, and linguistic isolation. Researchers, policymakers, and community organizations can use the database to target climate investment resources, develop targeted environmental justice initiatives, and prioritize infrastructure and resilience projects in these areas. If we look at the data that's included in the priority populations database, the database is available in a GDB file format. I'll include a link at the end of the slide and in the notes later for a tool that will convert this into a PostGIS compatible format. The data contains flags for disadvantaged communities, low income areas, and non-designated areas, and also includes shapes for buffering these regions. In the next slide, we'll create a status signals table to simulate some data from trucks. The status signals table is designed to capture comprehensive vehicle tracking and operational data, and it serves as a central repository for real-time and historical vehicle movement. The table includes geospatial and temporal attributes and includes a JSON-B column for flexibility of storing additional attributes. Here's the two schemas. The priority populations table is the table created from the California Air Resources Board data, and the status signals is a generic table that's created to be similar to other data that you may be used to visualizing. The requirements for the reporting are that the hours and percentage of total time when the vehicles are operating within a disadvantaged community are reported. The percentage of days when the vehicle is operating in the community is reported, and the total miles and percentage of total miles when the vehicles are driving within a DAC disadvantaged community for each quarter. Each report's broken into two groups: vehicles that are vehicle time and duration traveled in these areas, and vehicles that are domiciled or parked in these areas. As we start to look about how we would organize the data between these two tables, we can see that with the status signals, we need to create a line based on the points that we have in the system. We can use this with a common table expression and then also determine the length of the travel. And we'll do this before we associate it with any priority populations. As an example, looking at a data spread of 2 days with these blue lines in PG admin, we can see the travel of these routes of these high efficiency vehicles in the Los Angeles area. These show where fuel cell and battery electric vehicles were for a 2-day range in 2024. Only vehicles that have been acquired using the voucher program need to be scoped in the report. They need to be domiciled in California. Any vehicle report starts on the delivery date to the customer, regardless of whether it was in the reporting quarter. And here you can see that we have joined these two shapes and we're able to start to understand the intersections of them. Analysts are able to determine whether a vehicle's movement or domicile locations intersect with the designated disadvantaged community areas. The PostGIS extension provides the ability to provide powerful geometric intersection functions like ST-intersects and ST-within that can efficiently perform these complex spatial queries. The domicile analysis requires identifying the start and end location of vehicle routes that fall within priority population boundaries. This can be accomplished by aggregating the status signals data to determine the first and last recorded locations for each vehicle's daily operational cycle, then cross-referencing those points within the priority population's geometric boundaries. Such analysis can reveal patterns of vehicle deployment, potential environmental justice implications, and transportation service distribution across different community types. We report the hours and percentage of total time when the vehicles are operating within a disadvantaged community, a percentage of days when location and time of the first key on or last key off of the workday is in a DAC, the total miles and percentage of total miles when the vehicles are driving within a DAC community for the last quarter, and also the cumulative amount. Each vehicle report's broken into two groups: the vehicles that are domiciled in a DAC and the list of vehicles for each quarterly report. Other techniques that we use to help manage the data that we get are using truncated indexes on joins. With a truncated index, we are able to create index for sensor data that may not have an exact timestamp correlation. So for example, we have sensor data and we also have alarm data that comes from a different bus in the vehicle, and those time signatures may not always align. And so making indexes that are truncated on tenths of a second or hundredths of a second can help align sensor data for research and finding nearest neighbors in analysis. We partition and offboard the data frequently using DuckDB. The data is partitioned and stored in a Hive partition structure in S3, and then that becomes available to search using the analytics cluster at Crunchy Data. And then another tip that we have found very, very useful, especially when working with large data sets. We have over 4 billion points a day that come in. We wanted to identify the unique units that had transmitted data that day. Doing a distinct on a data set that size, very, very slow and very inefficient. And Depez, who maintains the Explain website, has a great article about how to do distinct items using sorted sets on very large data sets. Another thing that we do is we take advantage of Postgres being able to stream CSV data with CSV headers through standard out, and we bubble that up through the sockets in Rails. So whenever analysts are looking for data and they identify a search range and a unit that they're looking for, the data does not have to be assembled into a zip file and go through a download structure. It's just streamed straight through the browser socket to them. We use the listen notify structure in Postgres in order to be able to use triggers on the copy statement when we ingest data, and then we can notify on whether things are out of bounds for safety parameters and other things like that. And those we use the listen on a process in Rails, and then use the notice gem to send those communications out by email or Microsoft Teams or through other kind of like SMS notifications. We also discovered through unfortunate trial and error that creating millions and millions of small Parquet files is not efficient, and that the optimal Parquet size for us is between 50 to 400 megabytes. And I wanted to share that because there's not a lot of information online about structuring optimal Parquet sizes. But we did find with one group that had structured their files in small sizes with more frequency, that they reached an overhead limit with S3 retrieval. That was a bottleneck for them. Those are some tips that I would like to share, and when I have time and before this is published, I'll upload some notes so that those can be included in the descriptions for the talk. And that concludes the things that I have to share about the usage of PostGIS at Nikola for the community and the CARB reporting. And I don't know that there's much time left, but I do have a quick minute for some questions.
Awesome. Well, you do have a little bit of time left for sure. How did Nikola end up being a PostGIS user in the first place?
They ended up doing that because of me.
Well then,
So I had been a customer of Crunchy before I started at Nikola, and so I immediately started to advocate for a transition from RDS to Crunchy data.
okay, but they were a Postgres shop already.
Yes.
Right. You know what informed that choice?
Just Rails, I believe. Just
Okay, that makes sense. Yeah, yeah. Um, you got a huge amount of data coming in there.
yes.
Um, and so how do you deal with the fact that you have that huge data volume? Is it you handle like the clipping and sort of
Yeah.
reporting on the fly, so you don't have to do a big analytical run at the end, or
Right. So the data is it has a retention period in Postgres, and then it's expired through partitioning. The tables have a TTL. It's offboarded to Parquet files before that, and then so for the reporting, we're just reporting using Parquet.
okay, right? Have you started to run into any limits with that so far?
Not yet. We set up some initial trial runs with Glue and Athena and the analytics cluster, and we found the analytics cluster was about 5% faster on the data that we were searching. And that was the 50 to 400 megabyte files. Like, it was very simple benchmarking. We just did a select count over like a week's
Yeah,
worth of data, and looked at what that was returning.
well, that's really impressive. What's next on your Postgres and PostGIS agenda? What problems are waiting to be solved?
I think refining the CARB reporting
Yeah,
uh to use more SQL and less Rails. There's intermediary tables in the solution, and I'm not a fan of intermediary tables. So, I kind of think everything can be rolled up into one main query usually. So we'll make those changes. The data is going to continue to scale, so that will be challenging, and we're excited. We're excited to see what happens.
very impressive. Well, I really want to thank you for your time and for coming and sharing with us, Brian.